Welcome to my video tutorial. This one is dedicated to Ohm's and Kirchhoff's laws first and second one. During current lesson we will find all currents in each branch, and at the end we will build potential circle. So let's get started. First of all, we will build the following electrical circuit. It consists of 3 branches and respectively it has 3 nodes. First branch has voltage source E1 and resistor R1. Second branch has resistor number 2 and third branch has resistor number 3 and voltage source E3. Between node A and node B goes current I1, means goes through the first branch. Through the second branch from node C to node B goes current I2, and through the third branch from node C to node A goes current I3. Circuit elements such as voltage sources and resistors have the following nominals. Also, we know the potentials of each node, and we have to find all currents of each branch. To apply the Ohm's law, we have to find the voltages of each branch. First voltage will be UAB, voltage between node A and node B. The second voltage will be for the second branch, voltage UBC, between node B and node C. And the third voltage will be voltage UCA, between node C and node A. We found voltages of all branches. So now let's find currents which go through respective branches. I hope you remember my video tutorial about Ohm's law and examples dedicated to this law. If you don't, please watch this video again. For the first branch, we need to find current I1, which goes from node A to node B. In this branch we also see the voltage source E1. It has the same direction as current I1, so in equation it will be with plus sign. In the second branch we see only one resistor R2. Current I2 goes from node C to node B, so I2 is UCB divided by R2. Voltage UCB is minus UBC, which we found earlier. So I2 is minus UBC divided by R2. Current I3 in the third branch goes from node C to node A. In this branch we see voltage source E3. E3 will be with minus sign because it has the opposite direction to the current I3. And now let's try to build potential circle. For this purpose, we need to add additional points on which we have to find respective potentials. Potential circle in this case will have the following view. First of all, we have to start from potential A because it has 0 volts. Then we see voltage source E1, after which we set point A dash. Then goes resistor number 1, after which we see node B. Then goes resistor number 2 and node C. Then goes voltage source number 3 and point C dash. And finally the last element is resistor number 3, and potential circle must be closed on node A. Question: to build this potential circle, we need to know also potentials in point A dash and C dash. Let's start from the potential in point A dash. We have to add to potential phi A the voltage of the voltage source E1. Taking into account that this voltage source E1 goes from the node A to point A dash, so it will be with plus sign in the equation. And now we can find the last unknown potential in point C dash. Phi C dash is phi C minus E3. Why minus? Because we see that voltage source E3 has the opposite direction and goes from the point C dash to node C, so it will be with minus sign in the equation. Now we have all data to build potential circle. Let's do that. In potential circle, x-axis is resistance and y-axis is potential phi. Voltage sources, in particular voltage source E1, has vertical increasing on this potential circle. On resistor, voltage is decreasing, so on potential circle we will see slowly decreasing proportional to respective resistance. And the same will be for other elements. So we understood the principle, and now let's build the potential circle point by point. First point is the potential in node A. It's 0. So the point on the potential circle will be also 0, means the origin of coordinates. Next point will be phi A dash, 80 volts on y-axis. Point A is a potential in node A, and point A dash is a potential in point A dash. Potential in node B is 67 volts of direct current. On x-axis, we have to mark the resistance of resistor number 1. So now we can build the next point. Point B, potential in node B. Potential of node C is 79 volts of direct current. Resistance R2 is 10 ohms, so on the x-axis it will be the point of 15 ohms. And now we can build the next point C of the potential circle. Next point will be C dash. It will be the vertical decreasing of the voltage because voltage source E3 has the opposite direction from point C dash to node C. 9 volts will be right here. And let's build the point C dash of the potential circle. The last point is point A, from which we started. From point C dash to node A, we will get through the resistor R3. Resistance R3 is 12 ohms, respective value we have to mark on x-axis. The last point is built, so now we can close the potential circle. Our way was from point A to point A dash, to point B, to point C, to point C dash. And again, the potential circle is closed on point A. The same we built on this plot. Look at this circuit again. Remind again how to build the potential circle. As you can see, there's nothing complicated. And the last thing which I want to show in this lesson. Let's just imagine that our circuit is integrated in some larger circuit, in which branches we have to find respective currents. These currents will be additional currents I4, I5 and I6. We remember that I1 is 2.6 amps, I2 is 1.2 amps, I3 is 0.75 amps. Let's use first Kirchhoff's law to find additional currents. Current I4 is I1 plus I2. Current I5 is I2 plus I3. And current I6 is I1 minus I3. Now let's find their values. I4 is 3.8 amps, I5 is 1.95 amps, and I6 is 1.85 amps. Thank you for watching.